Hello and welcome to the Oxford Maths live stream. My name's James and this is a special episode where we're talking about interviews instead of maths. I just did 3 or 4 minutes of live stream talking to myself because I forgot to press the button but went live to go live. I'm so sorry. If you've been playing along in chat, that's at slido.com/matlive. And there's a vote going on for how is your day. I am so sorry that I just did 3 minutes all on my own. Thank you to the people in chat who said that it hadn't started and that they couldn't see anything. I was having a great time though. Right, okay, this is going to be a stream talking about Oxford interviews instead of the maths. It's a sort of bonus episode at the end of the year here. I think we're going to do about 20 minutes at the start talking about the who, what, where, when, why of Oxford interviews. But first I want to cover some sort of FAQs or things that people are asking in chat at the moment. I think I'm now live, by the way. Maybe somebody in chat will let me know. Yeah, Callie can see it now. Callie in chat is moderating for me again. Gosh, I'm so embarrassed. Although you didn't see the 3 minutes. I think I was really nailing it though. It was going great. Let's just do it again. Okay, right. So Oxford, I'm going to try and do information about interviews. Thinking about maths and computer science because those are the subjects that I know about. I'm the admissions coordinator for maths and I talk to computer science a lot. We have a joint degree. I'm doing this mostly looking at the 2024 admissions round for 2025 and 2026 entry. If you're watching in the future, then please do check the Oxford website for up-to-date dates and times and who knows, information like that, and hello from the past. But if you're watching live, then you have a poll to join in with to let us know how your day is going. 4 and 5 stars have just pulled ahead after a strong start for 2 stars. I'm always watching out for people who are having a just terrible day. So yeah, there you go. Sorry about that. I hope that seeing some interview stuff gives you something to think about at least, to maybe take your mind off whatever else is going on in a 1-star day. There they are. 10%, that's quite high. The questions in chat so far are asking about receiving interview invites. So I guess my main FAQ is the kind of when is that I'm expecting colleges to send out decisions either way to all of their maths or computer science candidates next week. That's the 2nd to the 6th of December. So everything's a little bit later than this year because Oxford term dates are a little bit later. We're doing our admissions process, as we always do, at the end of term, and Oxford term's a little bit later than normal. So it's a little bit more into December than it usually is. But there we go. So as far as I know, no colleges have given out any emails about shortlisting decisions. We're expecting those to be next week. And yes, that is everyone, whether you're being invited to interview or not. And I'm going to try and give helpful information today. I always do, but I'm going to try and do helpful information that's helpful to you, kind of whether or not you're going to an interview, because at some point in life, you might be interviewed for something, and at some point in life, you might have to do some maths problems. So maybe for some of you, that's coming up very soon to do both of those at once in a sort of maths interview. I think all of us are going to need some interview stuff as well. Right, okay. And there is a differential equation in the thumbnail. So if you're a big fan of differential equations, I'm going to get to that and talk about why that's an interview question that I've used in the past. But I'm going to get there after I've done the kind of who, what, why, when, where questions on there as well. Okay, let's turn off the poll so we can see chat a little bit as well. Just catch some stuff from chat. Oh, Horatio can do the question in the thumbnail. That's nice. International students get emails at the same time as other people. Emails just go out. Oxford can't see your TMUA score. I don't know, unless if you write it on a postcard and post it to us, then I guess we would be able to see the postcard, but we're not looking for your TMUA. Yeah, Adam says we don't care. Somebody's having a 5-star day because their friends are getting interview invites. Oh my goodness, somebody's going to use a Laplace transform. Just before we get to the differential equation in the thumbnail, the idea of the question is not to do a Laplace transform. If you know about Laplace transforms, go ahead, knock yourself out. But you may find that I want to ask you how Laplace transforms work and change my interview question to be talking about Laplace transforms. When I did that one with candidates, I would say nobody tried to do a Laplace transform. I wouldn't recommend. Try to do a Laplace transform. Haven't used most A2 constants since summer. I would encourage you to revise. Let's talk about, that's going to be in the what category, I think. Should we do some of these? I'm going to try and cover all of these. If you think your question that's in chat, if you think I've missed it, but it's covered by one of these categories, then let me get to it. We'll see. Okay. Right, let's do who first. So who, kind of you, one candidate. I'm recording this as we interview people one at a time. So one candidate, but two interviewers. So one of you, two of me. Well, there's only one of me, but two interviewers who might be tutors, or they might be people who teach on the course. So I'm going to put tutors or Oxford lecturers, maybe, or possibly grads. Possibly grad are default students with training, and they do quite a bit of training if they're joining in with interviewers. So two interviewers, usually at least one of them would be someone who is teaching undergraduates on the course at that college. One candidate, two interviewers in an interview to talk about maths questions. If we're interviewing for maths. Good. Okay. What? I'm going to go maths here, which is obviously a bit broad brush. Maths covers lots of things, and obviously if you're watching this and you're going to be interviewed for physics, then maybe that should say physics instead. So let's just remind people that I'm talking about maths and or computer science at the top here. And I do think maths is the right thing to say for what, even if you're applying for computer science. That's because, well, there's a lot of overlap between maths and computer science. Computer science is different from maths, I do know that, but I think to a first approximation, if you go in expecting maths, then that's the right sort of thing to expect. Okay, and so these are normally sort of 25 minutes. 25 minutes. My handwriting is worse than normal. How can I fix that? I can move everything around a little bit. Normally 25 minutes. Normally about 2 questions, but that's in heavy sort of air quotes of like about 2. What does 2 really mean? Because while I might ask questions about 2 different topics in an interview, within one of those questions there'll be lots of subparts. We're not talking about the mat today, but in a good mat question, there's lots of related subparts, right? And in an interview question, that won't be explicitly clear that there's lots of subparts. I wouldn't expect the interviewer to say part 2 and then go on and do the next thing that they want to ask you. But there might be a structure to the question that might build up piece by piece. From what's going on. In terms of content, basically anything in maths or further maths is fair play, I think. So if you're doing A-level maths and further maths, which most people we've shortlisted are doing maths and further maths or equivalent, I'm going to list maths and further maths here. I can't spell further. It's embarrassing. And my handwriting's so bad you can't tell if I misspell things. There we go. Tell me what's going wrong today. RE handwriting. I want to be really clear that if you think a question is based on something that you haven't seen yet, or based on language that you don't recognize, or words that you haven't seen, then you can ask for clarification. You can ask for help. One of the things I like about interviews is that it's a dialogue, that it's not just we print a question and leave you alone. We're there to help you. So I'm going to go with help. I've interviewed a lot of people over my years interviewing here, and I think everyone I've ever interviewed gets some help, gets some prompts. I think this is true. I think I'll go for the precise statement that no one I've ever interviewed has received no prompts. That the interviewers are there to help. They know how to do the questions, and they're interested to see you succeed. I am always trying to put people, if I'm interviewing a candidate, I'm always trying to put you in the position where you can do something. You can do the next bit. You can have an idea, or you can say something clever, or realize a connection between what's going on. And I might move that a little bit. I might change. Well, okay, this seems like a hard question. Let's think about something different for a moment. But I'm always trying to get the student to succeed. I would like you to get to the kind of point of the question if we can. So you should not go in, I think, expecting to only be asked about AS content. You might be asked about maths content or further maths content. I'm actually going to go /other as well, because I think sometimes people use interviews as a way to try and see what happens when you meet maths that you haven't seen before. So they might pick a maths topic that is nothing to do with anybody's A-level syllabus or equivalent or anything, and see if they can teach you a bit of maths live. Earlier there was some chat about Laplace transforms. Maybe I could design an interview question where I teach you what a Laplace transform is, and then get you to do some things to check your understanding of Laplace transforms. I think sometimes you see this in math questions as well, where the math question isn't really based on any specific item from maths or further maths. So I think because they're testing, because interviews like Matt are testing problem solving and testing kind of how you adapt to being stuck on problems, you might be covering content. You might be finding that you're saying things about content that you've never seen before. Okay, let's put some what things, some stuff in the what category about what's going to happen. The problems are hard. The problems are not impossible. You do not learn very much doing an interview if you give people an impossible question and don't help them. You see a lot of stuck people. You have quite a boring day. You don't know who to make offers to at the end. It's not helpful. So the questions are hard because people like you are watching this live stream and doing maths questions with us. So we have to pick hard things that you don't just do straight away. But they're not impossible. There's an element of sort of problem solving and I like to see people getting unstuck. I think my handwriting's improving. It doesn't get much better than this, sorry. So I like to see people who are stuck on something have an idea and get unstuck. That's quite hard to see if you're doing a test like maths, because maybe you have that moment where you realise what to do, but in an interview, I'm actually there and I can, help you get to that moment and then help follow up afterwards. Will we give you fake prompts to see if you're confident in your answers? I'm not quite sure what that means, but I think that's something like, maybe this is something like, the interviewer says, is this number prime? And the answer is, no, it's not. And maybe that's not what you're expecting. Maybe you're expecting all of the prompts to be yes, you agree. Maybe that's what that question means. So yeah, I've used prompts where I want someone to genuinely think about something rather than just agreeing with me. That can be, I don't know, maybe some people find that surprising perhaps, that I say, is this number prime? And it's a yes no question, and I'm not trying to bias this by asking you if this is prime, like hint hint nudge nudge, it is prime. I'm just asking you if it's prime or not. So if you're trying to get into my head to work out why I've asked the question, I think you should focus on answering the question, which might involve thinking about prime numbers. There's a little bit of trying to game things that sometimes doesn't help. Asking if you're sure when you're right. I don't think I'd ask someone if they're sure unless I think maybe, well, so are you sure is not a great prompt. The prompt I would use in that situation, if somebody says yes, for is it prime, I might say, why do you think that, or can you explain? I think either of those, I might engage with someone and question them further, hoping that they get to the point of realizing maybe no, it's not prime. I don't know. I'm trying to help. I'm trying to make you think. Good. Okay. Right. Okay. So we're going to do some math problems. I've got some specific examples of what coming up once I get through the FAQ stuff. At the moment, hey, somebody who's a first year math student, you did it! Hooray! First year. First year's a lot of fun. I hope you're having fun. They are doing a lot of problem solving and getting unstuck. That's why we do it. Can I do Y next? I have to do where is online. Oxford interviews are online for everyone. We've got a lot of experience of doing online interviews because we've been doing online interviews for international students who can't get to Oxford because it's miles and miles. And we've been doing interviews for overseas candidates for ages. And we've been doing online interviews for everyone for several years now. We think we can still do this, asking you questions and working with candidates in an online setting. Means you don't have to travel as much as you would if you came to Oxford. Anyway, right, what are we doing? Y. Should we do Y next? Y seems important. So I think that there are two ways I can go with Y. One is just, again, I've said this before, but like we've got a lot of applicants, which is a nice problem to have. It means that we get to meet lots of people. We want to do maths. We've already had one go at doing maths problems with you on the maths submissions test. For some people, we would like to have another go doing maths questions live in an interview to see them solve problems in front of us and give them follow-up questions. If you solve the first part of my question, I've got the second part of the question ready to go. And if you solve that too, I'm going to keep going until you get stuck. And my plan is for you to get stuck and then demonstrate how you get unstuck. So please don't be worried if you get stuck on a problem. We think that interviews are a bit like teaching on the course. Although for the teaching on the course, like the small group tutorials, there's less of a surprise element. People come to my tutorials on the course, having prepared in advance and tried things, working together and working at home, and thinking about the course material. Whereas in the interviews, I'm not trying to test what's your support network like. Can you talk to other people and get the answers to these questions? That's fine. I'd like to see you solve things live. Okay, what's coming up in chat? Oh, I've missed things. What if my connection cuts off? Will it be Zoom or Teams? Yeah, so online stuff. Online, we use Microsoft Teams. If there are tech issues, we're prepared. We've got backup plans for what happens if the connection is just not very good, or what happens if somebody's camera breaks or something like that, whether we can just keep going and carry on doing some maths. We've also got backup plans around rearranging interviews if we have to. So we might rearrange interviews if the tech's just not there, if we can't make it work. And try and shuffle things around and reschedule interviews occasionally. Please do not worry about internet connection. We will do our best to get through to you. How difficult are interview questions compared to step 3 questions? I've honestly no idea how to answer that. You don't get any help in step 3. You're just there on your own. In an interview, you get help. They're very different things. Shall I pretend to be stuck then unstuck amazingly? I would not recommend it. In general, lying is not a solid way to make progress in life, I think. What percentage of people get interviews? We're shortlisting about 30% of people at the moment, for mathematics at least, about 3 people per place. So we're interviewing about 3 people per place. We normally give people interviews multiple times, so rather than just having one interview, multiple interviews. so that we can try out different questions and have different interviewing teams meet different people. Those interviews might be with more than one college, but you will be notified by emails about what's going on if you're being interviewed. Right, good, okay. Will there be questions on personal statements? I have never asked anyone about their personal statement. I think some of my colleagues might, as a kind of icebreaker. I'm not really into icebreakers. I want to get on with the maths. Well, he says 25 minutes into a live stream where he has not done any maths yet. I'd like to get on with the maths. In general, I've got your personal statement. I've got your details of your UCAS application. I've got that separately. I'd like the interview to be something slightly different. Let's do the when, just to wrap this up. So I'm expecting emails. So this is brackets, there's not actually when, but emails I'm expecting to be the 2nd to the 6th of December. And for people watching in the future, this is 2024. Yes. Interviews are mostly, and again, I'm still talking about maths and computer science, mostly the 16th to the 19th of December, and a little bit the 9th to the 13th of December. I've written the wrong month on my notes. That's really annoying. What's the point of making notes if I can't even do them correctly? There are going to be a few, mostly towards the end of this week, I think, not so many on the 9th. We do try to give people 1 week's notice of interviews. See from the numbers. Right. Okay. GP's got an invite from Cambridge. Oh, cool. We're practicing with Oxford interview questions. Help me for my Cambridge interview. Yeah, I don't see why not, right? It'd be weird if they were different. I interviewed for Cambridge once. I interviewed 1 year for Cambridge when it sort of overlapped while I was in Cambridge. One of the questions I might talk about is based on a question we used many years ago in Cambridge. Of course I know him, he's me. Right, okay. How do you reduce bias? So you have all our information. So some tutors some interviewers like to interview without looking at details from personal statement, details from the application. They want to know as little as possible when they go into the interview to reduce bias. Some people rely on the unconscious bias training that we've done to mitigate unconscious bias during interview. So if you're aware of information, then you should be aware that you're aware of information and try and do interviews fairly for everyone. There's a lot of training for interviewers. Yes, I've heard in the other day that maths interviewers are scored between 1 and 9. Yes, the maths department, we love scoring things. We love numbers. What differentiates the candidates between 6, 7, 8 and 9? Yeah, exactly. Yeah. How well they've done. that's the thing, right? How well they've done. We have some criteria, which I might talk about. We will find out. I think that's my who, what, where, when, why. Yeah. Probably multiple interviews, so I didn't put that in the what's column. I should maybe put that in the what's column. That's maybe enough. Anybody got any who, what, where, when, why questions that we should do before we get on with talking about an actual question? And let me check, am I live? Phew, I am live. I don't have to say all of that again. Gives me, that really threw me. And also, you didn't see it throwing me. So from your point of view, I just came in flustered, which is not a good look. Right, here we go. If you get 9s in your interview, will you get an offer? Let's talk about offer making at the end. After this, one of the points of the why is that we're making offers. Of course, tutors have access to information from before, and final decisions are made based on all of the information, contextualizing things where we're aware of extenuating circumstances and everything else. At the end of the day, tutors make offers to people that they think have the most potential to succeed on the course, looking at all of the available information. So interviews are not a final hurdle, all or nothing, but we look back at previous information as well. There is no official weighting for these things. We have humans making the decisions, not machines. Humans look at things, and if you really care, there is a big final meeting where tutors from all of the colleges get together to essentially have a big argument about the final few offers that we're making. The decisions at Oxford made by humans, not by AI or machines with, these large models with all their weightings and things. We've got humans doing things. If you have extra time, we don't. Okay, so it's less common to get extra time in interview because there's less reading. If it's a processing thing, I think people have occasionally requested extra time in interviews. It's not as common because some people's extra time relates to reading specifically. If you are shortlisted, please talk to your college. If you would like things to be taken into consideration, if you think you're entitled to extra time as well. It's a big argument. Right, let's not talk about the large arguments I'm coordinating later on. We tend to agree quite a lot, which helps. We tend to agree. We're very cordial. Arguing's not the right word. Discussing. There you go. Discussing. I should say that you might be interviewed by 1 or 2 colleges, but your application can be seen by all 29 colleges that do mathematics if you've applied for maths. And there are colleges who will, well, no, I'm not specific colleges, but my prediction is that there will be colleges who make offers to candidates they haven't interviewed on the strength of the interviews as recorded by other colleges. Because if there's somebody who's missed out on an offer at their first college or the second college, that college might be keen. Right, okay. Oh, right, okay. Can I zoom this? What's gone on with that? That's not quite right. 2 seconds, just going to pause here. First thought for the thumbnail is y equals 0. Anna, save that thought. That is non-zero. I feel like there we go, that's a bit better. Here's what we're going to do. We're going to find some solutions to this. Okay, so this is an interview question that I used last year. Because I wanted to test people's technical ability to manipulate functions and take derivatives of things, of course. But also I wanted to see if they could sort of have ideas or be willing to try stuff or look for places to explore. And there's a kind of key step where I prompt everyone, more or less. And that's the point where I'm looking out to see, after I've given them that nudge, how much can they sort of take that forwards? Because I think that's a model for how later on in the maths degree they might see precisely this thing that I'm going to show you in a second, and whether they can absorb that new information, that new idea, and use it to move forwards. Or whether they get sort of so bogged down in the kind of calculation details that they can't keep track of what's going on. Right, okay. When will we find out if we've got an interview or not? Next week. 2nd to the 6th of December is when I'm expecting. That's the window where I'm expecting each college to email all of their Maths and CS candidates. Okay. Oh, what a great question in chat. I love questions like this. Could we use differential operators for this? See, this question in chat sounds, I hope you don't mind me saying this, it sounds really clever, but a differential operator is just d by dx. So what they've done is they've seen d by dx and they've said, can we use differential operators? And the answer is no. Like, it is a differential operator in front of you. You can't use it, you must solve it. Like, it sounds like it's a clever question, but it's actually just saying what you can see, which is fair enough. Say what you can see. Differential operators, cool, yeah. Derivatives. Good, okay. Right, okay. Some people want to try the auxiliary equation. This is going to be fun. We're going to split people up, aren't we? Whoa. We're going to split the audience because different people are going to try different things. I would like to talk about Anna's suggestion. Anna suggests y equals 0 works, which is true. And if you say this, then I say, great, that's a solution. It works. If you put it in here and here and here, then you get 0. Can we find any more? And there's kind of a split, I think, between people who want to try to just explore and find functions that work versus people who would like to hit this with some theory, possibly a Laplace transform. Okay, a function that does differentiation. Yeah, that's good. Right, okay. So some people recognise the type of equation, maybe. I don't quite know. I have put this x cubed on the front. I've tried to design the question so that it's resilient against some attacks that some people have learned, because I'm not really trying to test breadth of knowledge. I'm joking a little bit with the people in chat who have heard of Laplace transforms or auxiliary equations. I'm not trying to test like the breadth of your knowledge so much as like the depth of your, I guess, understanding for what you're trying to do here. You're trying to find a function. And I've helped people a bit when I've talked about this question before. A solution here means you're looking for a function y of x that does this, that when you differentiate it twice, one time and plug these things in, you get 0. So I really like trying x to the n. I like this because it's got a parameter in which we can tweak a little bit later. Remember those math questions where you try small numbers, or you try like, oh, is it something a bit like this to see if that works? That's nice. So now people in chat are going to try lots of different things. No, you can only get an offer from one Oxford college. That is part of the discussing that we coordinate later on if you're in the enviable position of multiple colleges. The one you applied to gets first dibs because you picked them, or the one you were allocated to if you made an open application. If you were interviewed by a second college, they get second dibs after that. Right, yeah, so this will, if you say something like this is an interesting thing for me because now I can test some of your technical math skills because I would like you to plug this in. And if you plug it in general, then it's going to be quite complicated, isn't it? Because it's going to be, after doing 2 derivatives, something like this. And, well, this is a mess, isn't it? This has got 1 extra power of x. So this is going to be some sort of, I guess, maybe a quadratic equation after we've simplified. And it's important to keep your head clear at this point. And to remember that we're just trying to look for some value of n that works. We're trying to find some solutions. So we're just trying to find some value that works. And yes, and some people are also trying to move the y on the right hand side, I saw. Or think about this as a quadratic. Yeah, so the x cubed out the front means, oh gosh, this thing is less like a friendly kind of thing and more like an unfriendly thing. Good. This is the point. Everyone's joining in with chat now. So Callie, who's moderating chat, has got a job to do. Yeah. Oh, imagine this part as the quadratic up here. Yeah. So the problem with this thing is not really the square of that thing. So good idea, but sadly, it's just not. There is a strategy where, so the person who shouted auxiliary equation is maybe thinking. I guess they're thinking something like this. Maybe they're thinking of trying e to the lambda x. That's a thing that you try sometimes. If you've seen a version of this with constant coefficients, then well, I'm sorry that this one doesn't have constant coefficients, so it's a bit of a red herring maybe. Does x equals 0 work for all n? Yeah, but so what, right? We don't really want to solve it just for a single point. We want to find this for all. I'm going to go for all x. Let's go say all x positive. That seems like a sensible range of x. X equals 0 seems a bit strange because either prefactors go to 0 or something. For any value of n in that thing. Okay, good. So n equals 1 is an interesting choice, which I like to see it. When somebody's got a complicated equation like this, and it's possible that what they're going to do next is to say, this is a linear expression in x, which is trying to solve the linear expression for a particular value of x in terms of n, but then there's like, it doesn't go very well. But if you set n equal to 1, then everything magically works, which is the function y equals x. And if you find the function y equals x, then I get a twinkle in my eye and I say, aha, can you think of any more solutions like that one? Because I'd like you to look back at the equation we started with. Yeah, this thing that you tried. N equals 1 is fun. These terms balance as well. It's lovely. But I'd like you to look back and think, can you think of anything else like that? What was that question about further maths? That was running past, wasn't it? If you've not taken further maths A level, not a requisite according to admissions requirements, will the question still be accessible? Some people applying from all over the world are doing other sorts of qualifications, and I can make this accessible to just about anyone, I think. I don't think I'd have to explain differentiation, but I reckon I can explain what we're doing from here, right? As we're plugging in x to the n, it's going to be fine. Cool. What's going on in chat? Oh yeah, look. Okay, so plus or minus x, very nice. Plus or minus, I think it's in trig form, is an interesting comment. If you say, I think it's in trig form, I will say, what do you mean by that? Can you explain more? And that's not an example of me misleading you. It's not an example of me leading you on. I just want to know what you mean. So sometimes there's kind of third category of question, right? I had this somebody in chat asked before about whether we give kind of fake prompts, and sometimes the question is just because I'd like to know. If you say it's in trig form, I can't see any trig on the board, but maybe you can, right? It's the lovely thing about seeing someone live. If you put that on a mat question, then maybe I just don't know what you mean. It's in trig form. What's the student mean? Whereas if you're actually here in an interview, we can have this conversation. We're going to have it through Slido, and you're anonymous, so I have no idea which of these people you are. Maybe that's what trig form is at the top. Don't know. Addy and Anonymous and Anna are looking at linear things. Oh, is that trig form at the top? Yeah, well that doesn't include the one we've already got, but you can try that if you like. So in an interview I'd say, aha, good choice. Does it work? I've seen this be the answer to questions before. I think it comes up in constant coefficient differential equations, and once again, this is not a constant coefficient differential equation. That's not supposed to be a trap, by the way. Some of you watching this, I think, have seen second order differential equations with constant coefficients, and some of you haven't, don't know what any of those words mean. I'm not trying to trap people who have seen it, but just like, if you've seen something, you have this kind of curse of knowledge, which means that once you've seen something, you know what it is, you have a responsibility to be able to identify it accurately. So if you've learned Laplace transforms and you want to do a Laplace transform, then you will need to know whether you can do a Laplace transform on this sort of thing, the product of two terms. You'll need to know what you're doing if you want to use that. So in general, you can use technology if you like knowing about second order differential equations, but only if you do it accurately. And this is not the style of second order differential equation that you see in A level. If you even see them in A level, again, some people have no idea what we're talking about here, but some people see things that look a tiny bit like this, but with constants. This is not one of those. And the answer to the question is not, I've seen this in A level. It's got one of those things, isn't it? Because it's not. Right, good. Okay. N is minus 1 over x. That is not a number, is it? Oh, I see. If you put minus 1 over x, well, then I'm going to say when you differentiated it over here, you thought it was a constant, right? Because you used the fact it was constant when you differentiated it as a polynomial. But you can't set 1 at minus 1 over x. It maybe looks like it works in this equation, but there was an assumption here that n was a constant when you said you would try. So now we're going to have another go, right? So sometimes people get themselves into positions where they say something that maybe they don't really mean, because well, a moment ago n was a constant, now it's minus 1 over x, but they're kind of thinking about it. Hold the thought though, because we'll see some 1 over x's later. Oh yeah, okay, right, okay. So, yeah, Laplace transform discussion in chat. Cool. Not where I thought we were going to go today, but here we are. I'm aware there are some people watching who are in first year of university, and you have even stronger curse of knowledge. Like level 2 curse of knowledge, where, oh my goodness, you've seen a lot of techniques. Remember, I'm asking this interview question to people who haven't started university yet, haven't finished A level yet. Cool, right, okay. If you're playing along at home, you can put a constant up front. This one works. Not plus b. If you said that, then I don't think you really mean it. I know why you said it, because add a constant, right? When you're solving these things, it's more general. Try a linear thing next. I think we should try ax plus b, but then we'll find out. Long story short, we'll find out that the b sort of dies here. It dies here when you differentiate, and it hangs around here awkwardly. It's not going to match on both sides. think that's true. Yes, that is true. Yeah, the B sort of just hangs around over there awkwardly. Yeah, good. Okay, so AX, please. Euro symbol. Good for set inclusion. Nice. Okay, cool. Once we found some solutions like this, and once I think that I've seen enough of the candidate trying some stuff, just finding out what works and what doesn't work, or recognizing that this isn't a differential equation that you've seen before, that we might not be able to just guess another solution. It's not something like this and it's not something like that. It's constant times x works. This is where I introduced the kind of content, or the thing that you learn at university, which is that once you've got one solution, which I'm going to call u of x, try y equals, am I going to call it, no, I regret some of this. I didn't quite say it like this in an interview. What did I say in the interview? I think I just said x. Sorry. It was a year ago and I seem to have invented. Once you've got one solution, x, try x times some unknown function f of x. Yeah, I didn't bring in the u of x when I did this as an interview question. Okay, so there's the idea that once you've got a solution, try that thing multiplied by f of x for some unknown f. And then it's over to you. And this is the point where if you're playing along at home, you probably want to get a bit of paper. If I'm interviewing, I usually use Miro. There's a bit of most colleges who are doing online interviews for maths are using Miro, which I've been using all year for the live streams. So you've seen lots of examples of Miro, and you have implicitly learned where the pen and the rubber are over here. I've been using Miro. There are other things that we can do if you don't have access to Miro. It's an online whiteboard thing. Good, don't worry about that. Okay, what was I saying about Miro? Oh yeah, so zoom out and have a look. Over to you. Yes, I was saying about grab a bit of paper. If you're playing along at home, grab a bit of paper. In an interview, you might have access to also write on an online whiteboard. I mean, I could write somewhere. Something. GP, hi. I don't know what the differential operator method is, I'm afraid. You tell me. I think a differential operator is a big category of things that includes d by dx. I'm not. The differential operator method in my head is there's a d by dx in the question. I don't know. I don't know how to go past that. Cool. Yeah, so Horatio, you've posted a solution before I started talking about the question because it was in the thumbnail. So you've followed through and found a solution. Might get you to check your solution, of course, if you follow all the way through. And you can check your solution once you've gone through all the kind of calculation stuff, and by checking it in the differential equation. I like asking people to check their solutions because it gives people one more opportunity. Does the solution of x mean a constant or some form of x with respect to y? Once you've got a solution, what do I mean here? Once you've got one solution, which for us is y equals x, sorry. There was a solution. Doop, there it is. I'm just saying, once you've got a solution, try multiplying it by f of x. So for us, that's x times f of x. I'm suggesting that we try that as our function for y. Then it might be x times some unknown. So I've taken the problem, find y, and I've converted it into a very similar problem to say, oh, what if it was x times an unknown function? Which is on its own stupid, because you can write anything as x times an unknown. Mumble mumble, dividing by 0, mumble mumble. Yeah. Do we end up with something times a derivative? I realise now this question is not very good over Slido. Online chat, probably not the right forum to do this. Yeah, it could be a constant. We should get that back at the end actually. If we go and solve for f, then it should be the case that f could be a constant, because that one you already found this. If you notice that, you're allowed to say it. That does work. We are going to hold that in mind because we should check at the end that we get f could be a constant. What I'm looking for, I think, is whether people can take this expression and plug it in to go and work out the consequences of, if this is the case, if y is equal to x times f of x, then the derivative is, and at this point we need to know how to find the derivative of x times f of x, which, when I've been interviewing people, by the time we get to interviews in December, I think most people have seen the product rule. So most people can see the product rule. This feels quite nice after months of not using the product rule for maths. I can now talk about the product rule. Look, you can differentiate things. I reckon you've learned this, or you're about to learn this in the next week or so. If you haven't seen how to differentiate this, and that did happen a couple of times in an interview, you can say, I'm not actually trying to tick off, have you seen the product rule yet? If you haven't, that's fine. It did happen a couple of times that people had not seen the product rule, in which case I can give you this. There's no way to do that with a maths sort of paper, right? I can't say on the math paper, if you haven't seen the product rule, tick this box or something, and then a hint appears, and then it says, oh, here's the product rule of this. Anyway, dy by dx squared is not the same thing as the second derivative. Now, second derivative means you differentiate again, you apply the differential operator, as GP would say. You can do some abstraction. Cool. I would encourage you, I think. If you're doing some substitutions, I'm doing a substitution. There we go, good. Adam is on that as well. Not going to stand for this squaring. Oh, so is anonymous. Would there be a silly question? I think that would make me think that you'd never seen a second derivative, which would be unusual because, well, it's on the math syllabus to know what a second derivative is. On the other hand, everyone does silly things under pressure in interviews. Probably time for me to share one. When I was interviewed long ago, there was a point I was doing a probability question. It involved rolling a die. I can't remember exactly how the question worked, but there was this fraction 5 to the 4 divided by 6 to the 4, and 17-year-old James tried to simplify that by crossing out the 4s to say this is 5 over 6. Because, do the same to the top and bottom, right? Crossing out 4s. So this is 5 over 6, and then carry on from there. The interviewers caught me and said, well, that doesn't work like that, right? I think everyone has these moments under pressure where you say something. The unique thing about interviews is that we can catch them, and then we're still allowed to admit people, even if they say things like this. Right, Worcester second year forgot what an even number was in their interview. Yeah, they probably didn't. Yeah, okay, right, good. That sounds like that's upstaged my story. That's brilliant. Okay, Worcester is in Oxford College. Adam's saying that they're at Oxford. Right, okay, substitute e to the u. That's exciting. Okay, right, do your own method. Carry on. Let me know if it works out in the end. I am doing the question this way because we're pretending. It's quite hard. I'm currently interviewing about 115 people. Hello. Normally I'm interviewing one person. 115 people doing the question in, as far as I can tell, about 115 different ways. Normally there's only one of you. I'm having fun though. Cool. If you plug these in, then you get down to, after a bit of substituting and a bit of chat about whether x is 0 or not, at which point I might just tell you that x is positive, you might get down to the statement that, where am I looking? I'm reading off here. Oh yeah, x squared 2 derivatives of f. I'm now using primes for derivatives, it seems. Mostly when I interview people, they use whatever notation they like all the way through. You might get something like this. A moment ago, I saw someone in chat tell me that means it's an exponential. Slow motion, please. If you jump a step, then I might get you to spell it out for me. That's partly so that I can check that we're not guessing and that we're justifying stuff, and partly because I want to give you the opportunity to relish the moment of doing the thing correctly and accurately and explaining what's going on. So if you just say, oh, it's an exponential, then I might say, well, let's find out. Can you show me how you would solve this differential equation? Also, because I don't want you to miss the constants. There's several ways to do this. At this point, I've usually tried to pause and get the candidate to say, well, what have we achieved? Is this good? At some point, people might try rearranging this. One direction you can go is to rearrange this as something like this, which is not too bad at all, which is a sort of separable thing. You can integrate both sides, you can make great progress that way. Some people might write down something like let u of x be the derivative of f, and then that's nice because now you have first order differential equation, if you know what those words mean. First order differential equation, like that. Oh, hi Sophie. What was f defined as? The first f appeared here in this advice that I give the candidates when they're Stark, and everyone gets Stark because it's really hard to solve this equation. It's not one you've seen before. Once you've got one solution, y equals x, try x times f of x. Once we found out that x works, try f of x times x. We've already seen that putting a constant there works. I think Anna told us that first. Putting a constant there works. We'd like to see other functions that you could put in here. And then we've just been following through the consequences of that idea. So the idea was to try x times f of x. All the y's are slowly turning into f's as we replace the y's with f's very carefully. As we follow that through, we get a differential equation for f, which we're then going to solve. And this is now more of an A-level exercise to just finish this off to solve for f of x. And you can do this by integrating factors over here, if you know what those are. If not, I can help. If you separate variables like this, then I can help you integrate both sides, or suggest that you kind of rearrange it to get the f's together and see what you spot. You know, it's one of those things where the derivative is the fraction of the derivative on the top of the thing that's below. Good, right. If I dropped a minus sign or something, whoopsie doops, it's my least favourite thing to see in chat. It's probably a minus sign, isn't it? We'll leave it. Good, leave it in. Warts and all. At the end, I think you get a solution to say that f of x, after all of that, is something times e to the 1 over x plus a constant. There's a lot of integration going on, so the constants shouldn't be too surprising. There's the constant Anna was talking about, that you could just have a constant, but there's this extra solution. And the last step that I put at the end of this question is to check that people understand what's been going on and that they can get back to what y is. Sophie says spotty internet, but other people might have other ideas. If you've been watching, hopefully you can remember that y is x times f of x. So just to put this back in context, this gives us the solution like this, and it also returns the solution that we already had, the kind of constant of integration. Gives us c times x, which is nice. There's a discussion we can have there about how it kind of replicates some of the work that we did before. Yes. Should have been x cubed in front of f prime prime. Disagree, I'm afraid. Why do I disagree? So my f prime prime comes with a factor of x, which is kind of followed through from the definition up here. It's sort of hanging around in the second derivative, and then that's multiplied by x cubed, but behind the scenes I've divided both sides by x squared. So I really do want x squared over here. Good. Ax plus b over x from Wolfram alpha. Oh, wow, this is good evidence, isn't it? If you were considering getting through an interview by putting everything into Wolfram alpha, well, my recommendation is don't do that. But my second recommendation is to type it in exactly how it is. I don't know what's happened there. Yeah, what's an integrating factor? It's a good question. So over here, there's a technique for solving these where you spot, do you even need an integrating factor here? Maybe you don't. Maybe you do. I don't know. There's a technique for solving equations like this. I might say, have you seen integrating factors? If somebody has got this equation but hasn't seen integrating factors, I think I would encourage them to do something a bit different. kind of the point of turning it into a first order differential equation perhaps is that you can then use an integrating factor. The idea is quite fun. It's that if you've got a differential equation of this format, I'll write it out with y's so that you can take a screenshot and say that you've learned a thing today. If you've got an equation like this, we're about to hit our 6 o'clock pause, but first I'm going to teach one person integrating factors. That's what I've decided to do. The other 115 of you are welcome to hang around. If you've got an equation like this, have I done this right? Yeah, it's 0 on the right hand side. Yeah, I mean, we could have a thing like this, couldn't we? If you're trying to solve this, the idea is that you multiply, and this is mad. You'll love this. It's a big exponential. And it's a big exponential, and then the thing in the exponent of the exponential is an integral. I'm stalling for time so that I remember what to write here precisely. What do I write here? It's the integral of p of x, isn't it? Because then it's been differentiated. Yeah, I have to put a dummy variable in here because I'm going to put an x at the top of the integral. There we go. You multiply both sides by something like this, where you integrate this function p of x. You integrate this function p of x. That's rubbish, I don't like that. One colour only for writing. I've remembered people don't like it when I write in pink. Multiply both sides by this, and then the left-hand side magically becomes exactly the derivative of this expression. Ugh. And it has been differentiated by the product rule, right? The first thing that you'll see is dy by dx times horror show. And the second term is the y has stayed on its own, and this exponential has been differentiated with, a combination of the chain rule and the fundamental theorem of calculus, but don't worry about that too much. It sort of matches up. On the right-hand side, let's put a big derivative around this, actually. The things on the left are the derivative of this, and on the right we've got, well, horror show, but it was already an arbitrary function q of x, so it kind of hasn't really got worse, it's just got hairier. If you then integrate both sides, you're done, because then you've got y times known function, and on the right, if you can integrate that, then you're good. That's integrating factors in 2 minutes. Sorry if you were trying to learn that for an A-level exam at the end of the week, but I think we made it in time. Thank you in chat as well for this integral of p of x thing. Am I supposed to know this for the interview? It wouldn't hurt to know this. There's nothing that it would hurt to know. When I'm asking questions, I know that some people have seen some content and some people haven't seen some content. If you've seen it, I would like you to be able to do it. But I'm always encouraging people to tell me if they haven't seen something. This is one way to do the question, if you know about integrating factors. Different way to do the question is that I might encourage you to rearrange this. If we've got time in the interview, I might encourage you to rearrange this until it looks like this. Kind of separate out the f's and the x's, I might say. Because I'm hoping that you can integrate the right-hand side. And then maybe I can tell you that the integral of the left-hand side, I don't know, I might encourage you to get the f's together and get the x's together and say, right, we're going to integrate both sides. I'll tell you the integral of the left-hand side if you can integrate the right side. I can get you to join in along the way with content that you have seen. I wonder if this question about pretending, I was told to not say I knew how to do it, feels dishonest though. Yeah, that is dishonest. I agree. I also think it's less, I don't know, we've selected maths candidates, not actors, and I sort of think, you're probably better at maths than you are at acting, so I would try maths first and then acting is a kind of backup plan. So if you see a question that you've just seen before, you know how to do it because you've seen something very similar before, then just say that. The interviewers will give you a different question, something else. I think you deserve that, really. If you do this kind of act or pretending or something on a question that you've seen before, then afterwards what you might think is, what if they saw through my act, and would I have been more convincing if I'd actually solved the question that I hadn't seen before? and maybe I wish I'd seen a question that I hadn't seen before and solved it. You might regret afterwards. This is the thing I worry about. Also, I think the questions are too hard. I try really hard not to ask people stuff that they've seen before. He says, preparing to launch into an interview question that he talked about last year and the year before. So if you've seen the show before, if you're here from last year, I talk about this question every year. I love it. I can't use it in interviews, and I want to talk about it, so I've got to talk about it here. Right. Now, Rob's done Gold DofE. Good stuff. That's the one where you have to do loads of different things. Right, at 6 o'clock, I'd like to remind myself that I'm human. I need to blink, look up. If you've been looking at a screen for the last hour, then remember to look away from the screen. You know it's the triangle in the parabola. I love the triangle in the parabola. I also talk about it at open days. That's the other time I'm allowed to talk about the triangle in the parabola. I have 2 different questions about triangles and parabolas though. Is it the one that you're thinking of? I've got 2 of these. I probably shouldn't say that there are 2 different occasions where I've interviewed and done questions about triangles on parabolas. People might think I have a type. Just to be clear, now that I've done that joke, that's not... I think I can never ask a question about triangles and parabolas ever again. I mean, I asked this question about triangles and parabolas quite a lot already. Right, okay, here's a triangle. This could still be either one of them. It's got 3 corners, A, B, and C. B is the origin in this B is the origin, and all 3 points, I should say, lie on the parabola y equals x squared. I'm doing a bad job of doing this question because I've made myself laugh. It's the cooled shot that's really got me. Right, okay. There's a parabola, y equals x squared, and there's 3 points on the parabola. The middle one is the origin. A is somewhere on the left, C is somewhere on the right. I want triangle ABC. Oh, excuse me, triangle ABC to be a right angled triangle. No, I don't. I want it to be an equilateral triangle. What am I talking about? Whoa. 1 hour into the live stream, now that we've made it to 5 past, after I started late. It's not the one where you maximize area by moving B, it's the other one. Right, okay. Have I heard about the Econ Olympiad situation? No. Yeah, okay. Oh, you have a serious question as well. I think you can ask... I've tried a mechanics question before. I find myself pausing quite a lot to ask what sort of mechanics people have seen, and I sort of worry that if you do a mechanics question, you're kind of just testing perhaps what order people are doing modules in, or which particular bits of mechanics they have recently seen. That people see it as quite separate knowledge, and they tend to be not as strong on their mechanics knowledge, and then you don't really feel like you've tested the... I don't know. I think some of my colleagues have done mechanics questions as well. We're aware that some people don't like mechanics at A level. Statistics are a little bit different, because statistics, probably people watching this at home might mean several things by statistics. And they might include a whole bunch of probability and counting and combinatorics in there. And I think all of that's really fair game. I mean, it's on the MAT syllabus, the kind of counting, probability, combinatorics. How many of these would there be if you took all possible combinations of all of the coin flips and dice rolls in the world all at once? Oh, yes, sorry, I haven't put the question on the board, have I? It's where should I put A and C? This question's got several parts. That's not the whole thing. I have, while laughing at myself, accidentally spoiled one of the later parts of the question. But yeah, here we go. There's an equation. Anna's first thought is c squared plus c to the 4 is root a squared plus, or a to the 4 is c minus. All right, okay. There's at least 3 thoughts in there, Anna. Give yourself credit. There's an idea to label things. There's an idea to write down, I think, distances. Hey, somebody else says AB equals BC equals AC. That is one equilateral triangle-ish. Go for it. Sounds like a like combinatorics. I just did the worst impression of all combinatorics questions all at once. I mumbled something about dice rolls. No, I do like combinatorics. You can do some fun stuff there, including stuff that doesn't need much prerequisite knowledge. That's the dream, really, when you're writing interview questions, to come up with a question that doesn't need too much. You're not getting bogged down too much in explaining integrating factors to people, and you kind of let candidates solve something and have an idea. The differential equation question we started with is okay, I think. It mostly showed me about technical skills. I was pleased that I paired it with a different question, which had more of a kind of, you need an idea to get through with this. I had 2 questions in that interview. Square roots. Like combi and hate geometry. Well, I'm sorry, but I got a triangle on the board and we're going to talk about it. You have the option of turning it into an algebra question as fast as possible. That is secretly available to you for most geometry questions. It's the option to convert it into an algebra question at the first opportunity, cross out all of the diagrams and solve the algebra question. You can get surprisingly far with that approach. Also, you might like algebraic geometry at university. Right, anyway, so what was I saying? Oh, can you put anywhere without loss of generality? Now, that's a good question, because I think you will lose generality if you put A anywhere. I might say, what do you mean? What are you going to do with C? I might change focus so you say C, because then maybe you will say, well, I'm going to put it at the same height. And I'll say, so is it true that if A and C are at the same height, I'm trying to rephrase your question if it's true that A and C are at the same height, then wherever you put them, you get an equilateral triangle. And you will say, no, that's not the case, because it's not the case. Right. Yes, okay. Some people in chat are doing some solving. The point I want to make with this part of the question really is that there are multiple approaches that work. There are lots of things you might write down. Possibly, you might write down something to do with side lengths. If you're playing along at home, partly this is for me to know whether people are playing along at home or just sort of, you know, just sort of watching, which is fine. What was your first idea? I quite like to do it as a poll. So the options are going to be side lengths, angles, symmetry, and something else. And then we're going to try and talk about each of those things. Start interaction. Oh, can choose multiple? No, you cannot choose multiple. And I don't want to show you the correct answer because there isn't a correct answer. Right, okay, people are voting in chat. Perfect. Look at this data gathering exercise. What was your first idea? I think this thing about same height maybe counts as a symmetry thing. If that's your first idea, then it's not obvious which one you're going to pick. You might think of that as maybe a side length thing, or you might think of it as just sort of symmetry. It's obvious because equilateral triangles are symmetric. That's fun because then we can have a discussion about that. Symmetry is one of those things where when I'm interviewing candidates, I've noticed that candidates tend to just sort of say symmetry, and then you need to do like a follow-up question to find out what sort of symmetry they mean, rotational, reflectional, and then you need to sort of chat about how do you know the solution has that symmetry. It's true that an equilateral triangle on its own has reflectional symmetry about some axis. It's true the parabola has reflectional symmetry about some axis. How do you know those things are going to line up? We can have that discussion. Symmetry is often quite tricky. Yeah, lots of stuff. Pythagoras is probably relevant, at which point we pause the poll just to acknowledge that just as Pythagoras becomes relevant, the person with the username c squared is b squared plus a squared enters chat. Good to see you. We may need you in a second. Yeah, there's people posting lots of algebra in chat, which is fantastic. Love to see it. Let's agree on some notation. And when I say agree, I mean I'm going to pick some notation. You can use your own notation, of course. It's one of the beauties of you being there for the interview, I guess. But I'm going to use this. Why is that selected my parabola as well? How would I get it to not do that? Okay, I just move the question down a bit. Anyway, okay. So lots of people saying side lengths. Some votes for angles kind of equal with symmetry down there. Yeah, does the null triangle count? Is a question from maths22222 in chat. It's like saying 0 in the previous question, right? Kind of, yeah, sure, that counts a bit, but we're still going to do the question. It's 2 questions in a row where the 0 thing maybe works, sort of. Oh, it definitely works in the difference equation. I have some feelings about whether or not the null triangle counts as equilateral. Are its sides the same length? Does it have any sides? Doesn't matter if it has no sides. Yeah. Hard pressed to say that its sides are all different lengths. Yeah, cool. Okay, yeah. Vectors. Oh, yeah, I love vectors. You've got to do something with the vectors, though. So I hope it's fair. Maybe you didn't fit precisely into one of my categories, but you've got to choose what you're going to do with the vectors. Maybe you're going to think about their angles to the x-axis. Maybe you're going to take some dot products. Oh, gosh. I haven't done this question with vectors for ages. What are you going to do? You're going to insist they have the same magnitude, perhaps? If we're thinking about the vector from B to C and the vector from B to A, you might insist they have the same magnitude and that their dot product is something to do with those lengths. Oh my goodness. We would like conditions on A and C to know where to put these. It is not always isosceles. It's not always an equilateral triangle. Case in point, see this picture on the board, which is not an equilateral triangle. And keeping A still and moving C seems like a disaster. And if A and C are both very small, then the triangle has a very large angle near B. That's something that you might say in an interview, or I might prompt you to say if we're having this discussion about is it always an equilateral triangle? Of course not. Oh, area. Areas. Oh, I've never thought about doing this question with areas. What is the area of an equilateral triangle? It's like √3/4 times the side length, but I don't know the side length. Okay, let's talk about those approaches then. In order of popularity, reverse. So something else we've discussed in chat a little bit. There's a symmetry argument, which I think says that A should be minus C. They should be on opposite sides and at equal heights. Maybe you think that A squared should be C squared, but you don't think that A should be C, you think A should be minus C, opposite sides. That maybe comes from thinking about how the side length of AB is the side length of BC. So maybe you had this idea, but you thought about it from a side length point of view. The tricky thing is that triangles have 3 sides, and for an equation, you only need 2 things. So you have a choice, which 2 things? And if you pick AB and BC, then you get this kind of fact that says, aha, this distance and that distance. Maybe you follow that through from Pythagoras to work out those lengths in terms of A's and in terms of C's, set them equal to each other, solve. Or maybe you think, it's pretty obvious, they're going to be the same distance up, symmetric parabola, lefty, righty, A's minus C. Either way, we can have that discussion. Have I done this question on another live stream? Oh yeah, I've live streamed about this question maybe 10 times. It's my favourite. Good, right, okay. There are some angles going on. Maybe I need to retire it. If we're getting to the point where people in chat are both predicting that it will happen and playing along, recognising it as it happens, maybe I've talked about this too much. There are a bunch of angles that you might talk about. If you've had the symmetry idea, those left and right angles there, you might realise that they're both 60 degrees. Either way, you might know the angle in between the 60 degrees. That might give you ideas about, I don't know, the cosine rule, sine rule, areas, vectors, dot products, loads of things based on angles. Yeah, okay. Number theory next. Yeah, good, okay. That gives you a different relationship that you can write down between A and C. There's a key fact that we haven't used yet, which is for an equilateral triangle you need AC. Also, AC should be equal to BC or something, which is some equation which you can rearrange and solve, or you might use this 60-degree fact. The 60-degree fact is actually pretty good. Let's draw a triangle here. The 60-degree fact says that you've got this kind of right angle triangle going on with base C, height C squared, a 60-degree angle. It's all rather nice. C is tan 60. That feels rather nice. If you like trigonometry, then hey, it's just tan 60, which is, oh gosh, √3, something like that. Good. Does it seem too easy? It does seem quite easy. That's because it's the first part of the question. the second part of the question is kind of what other triangles can you make? And at this point, we normally pause in the middle of the interview and have a bit of a chat about other triangles that you can make. If we haven't already had the discussion about symmetry and about what happens as you move A and C further away from the origin or close to the origin while keeping them at equal height, we might have that conversation now. You can make lots of isosceles triangles like that if you move A and C like that. And if you put A on one side and C on the other, it's not obvious what sort of triangle you'll get at all. Which is why the other part of this question that I've done, and I usually haven't had time to do more than this, so let's go here, is to say, forget this. Now I want triangle ABC to be similar to, oh, that has not worked at all. 2 seconds. Was it underneath the chat? No, it was visible. To be similar to the 3, 4, 5 triangle. That's my favourite. I would like ABC to be similar to this triangle. And I'd like a solution where it does that. So, same setup. You can repeat your notation for what these things are, but I would like the triangle, instead of being isosceles, I would like it to be similar to the 3, 4, 5 triangle. The question is still, where should I put A and C? I'm messing around with moving and deleting stuff, which I don't normally do. Okay, let's just keep everything together. So probably none of this is true anymore. There we go. New question. I'd like it to be similar to 3, 4, 5. B is still the origin, and it's still the y equals x squared parabola. Let's keep B there. Cool. I think no stats today on my set list. Not planning to do any stats. I think I've got time to do a bit of number theory in a minute once we've light work of this 3, 4, 5 business. Yeah, okay, and then maybe we'll have a vote. Setup reveal is cobbled together from whatever we've got. I still have the microphone I bought for the pandemic. Good question. Right. There's perpendicular gradient stuff. How much are people joining in with this? It would be fun if we used areas, right? Okay, so if you have one side length, hear me out. I'll do the areas thing for a moment. If you knew one side length, then you know the area is supposed to be 6 times that side length. If it's the 3 side length, I think. If you knew, okay, the side length's not actually going to be 3, it's going to be something, and then the other one's 4 times as long, so the area is 6 times the square of, no. There's a scale factor compared to the 3, 4, 5 triangle, and it's the square of the scale factor that's important. So work out your scale factor in terms of hypothetical edge length versus the number 3. Square it, multiply by 6, and that should be the area of the triangle. But how do we know the area of the triangle? Well, we'd write down something like Heron's formula. This feels like the meme where I've got all the connected bits coming together. Heron's formula for the area, which almost nobody knows, but you can write down this formula for the area of a triangle. Why are we using areas? Write down this formula and then go for it. Yeah, there was a loud howl from outside. Sorry about that. I wasn't really sure if the cheap microphone from the pandemic would pick it up, but sorry if you heard some noise coming from Oxford. I'll ask them to keep it down. Right. Oh, when do interviews come out? Interview invitations and shortlisting decisions are being sent out by colleges for maths, computer science next week. That's the 2nd to the 6th of December. I think in that window is when each college, if you have a friend who has applied to a different college, they will get an email at a slightly different time to you. Please don't panic. The colleges handle communication with applicants, so they're going to go out slightly different times for the 29 colleges that are interviewing for maths. Do I have to remember my personal statement off by heart? Gosh, no. My word. Ugh. I don't like that idea at all. I've never asked anyone about their personal statement. Don't think I'm going to start doing it now. Do I know about physics? No, I know nothing about physics. Sorry. Coordinate geometry is the key. If you would like to annihilate all geometry questions, in the plane and just turn them into algebra questions. Then coordinate geometry is your friend. Off you go. We've given things coordinates, actually, so I'm kind of doing that already, right? A good idea is to try at least. What am I doing? How do I use this? Try being the right angle. It makes your life easier. Maybe we'll find a solution like this. If not, maybe we'll try something else. Putting the right angle over here or something. Right angle over here or something. Yeah, good. Okay. Yeah, so we know the side lengths are like 3 times the scale factor and 4 times the scale factor. Good. Do maths and CS applicants have 2 interviews in maths and 2 for CS? Usually, separate colleges, yeah. There are many solutions. We're going to find a solution. I've usually brought that up. Cool. What's this? Oh, yeah, dot products. Fine, off you go. You also maybe know something about gradients of lines. So there's some fact about gradients of lines. The gradients of these lines, if I'm thinking about the line going along the side, each side, the gradients of these lines are beautifully, voice crack on the word beautifully, beautifully C and A, because of how parabolas work or something. Feels like something Isaac Newton would have liked. Anyway, that gives us AC is -1, which is a different condition. Before we had A equals minus C, now we have AC is -1. And then there's a game again to use this 3-4 fact to talk about how you've got. We talk about how we've got 3 times the scale factor and 4 times the scale factor, kind of the ratio of the sides. Maybe this way around. There is another solution with these the other way around, but we can write down again side lengths maybe for what's going on there. What's this question? Make it a right angle triangle in general, or make it a right angle triangle with a right angle at B. So what I wrote on the board was make it similar to the 3-4-5 triangle. In an interview, I can prompt people to just try and find a solution where there's a right angle at B. We do not generally solve. I don't generally solve this one in full generality in an interview. We find some solutions that work. Do some more calculations. I make it clear when I'm interviewing people I'm looking for a solution. In general, my preference is that, well, this will sound a bit silly, but if your search for finding all solutions prevents you from finding any solutions, then that's a bit sad. And what I prefer personally is to find a solution. There's probably some other mathematicians who disagree with me on this, who say that it's better to find all solutions or fail trying. But I usually think that finding a solution helps you a bit. At least now you know solutions exist. Maybe you can think of other ones that are similar, or use reduction of order. I forgot to tell you. The differential equation. That technique is called reduction of order. Somebody asked in chat, and I forgot to say. Right. You can differentiate both sides and end up with first order. That is homework for me. It sounds a bit unlikely, but it sounds quite unlikely. I'm going to have to try that. I haven't tried that before. Differentiate both sides. Right, okay. Could the right angle be at A or C? Yes. And there are more solutions with the right angle at A or C. Yeah, of course there are. I think. Yes. The kind of hard follow-up question on this is what sorts of triangles can you make? And I think it might be all of them up to similarity, but that's too hard. So we've got there for a discussion at the end if I've got time and somebody's blasted through all the calculations. GP, imagine what it feels like to be a Cambridge PhD student who graduated and then went to Oxford to run the live stream about Oxford interview questions. A little bit different, isn't it? Career options with maths? No, you're going to be fine. Loads of people want to hire our students, and I suppose long term our applicants. Came out weird, but I think it's probably true. Lots of people want to hire our students. We have Career for Mathematicians Fair, which is held in the maths department. Lots of employers turn up to try and get graduates interested in coming to work with them. Right, yes, sorry. Hi, computer science and philosophy interviews. Good question. I'd expect that computer science So I'd expect the computer science interview to be more mathematical than you might guess. I have a reference for this, which I will put on screen. One of my colleagues in the computer science department, their name is Varun, they have got a kind of blog which they updated. They updated this in June last year. They have posted some interview questions that they've used for CS to talk about, or to show you examples of what they've been using as interview questions. They're a computer scientist. I think their interview questions look really mathematical, possibly surprisingly mathematical, you might say. So if you want to find these because you're a computer science applicant and because you would like a question with pi squared over 6 in it, I don't know who of us would not want a question with pi squared over 6 in it. You can find these if you search for my colleague Varun, who has posted 6 of them on their blog. If you find this, I guess you find their website and then hit blog, and then find ones from. I'm on a tag with tag Oxford, so you can find these. And some of them come with a discussion as well to talk about why they did this. Good. Okay. So suggestion for CS people or maths and CS candidates. You can get 6 more questions after the show from this blog. Right. Good. Let's put that here. Okay, what are we doing? How are we doing? Right, that was nice. I suppose pi squared over 6 was on chat briefly. Adam's going to differentiate my ODE. Can't wait. Right, okay. There's a number at the end, which I can't remember at all. I think there's some square. I remember some 16 over 9 factor. The algebra is a little bit fiddly for this one. I'm not super excited by the answer at the end. There's a fun step 3 question involving complex numbers. Good. Okay. Right. Bit of number theory. I have one kind of number theory question that I talk about on live streams sometimes. It's a bit easy. It's from an interview where we had multiple questions, and there was. It's not how I run my interviews now, but we had an interview with smaller bits of question. It's the 100 factorial one. If people have seen the show last year or why are you still here if you saw this last year? But if you've seen, I've done other events where I've had to talk about an interview question, and I usually pick this one. So if you're still with us at 6:30 here, I'm now going to talk about a question that you might have seen before. I might have already done that, but I'm now going to talk about a question that you might have seen before. If you want to see it anyway, or if you don't know what I'm talking about, then buckle in. Let's do some number theory. So the question works like this. Starts by asking you about prime numbers. We did a warm-up for this at the start, didn't we, by talking about when things are prime or not. Is the primes on? Let the primes on. What was the answer for the equilateral one? Oh my goodness, I didn't even write it down. Yeah, sorry. It's something like 16 over 9, there's a power of 4 over 3, I think. There's some just horrible numbers flying around, sorry. And then the other one's minus 1 over that or something. Sorry, not to be more helpful. The ideas are much more important than the final numbers. Sometimes in interviews I have said, let's not actually work out this calculation, let's move on, because we don't need to get to a number at the end. I've seen enough to know that you solved it. You had an idea that I know this idea will lead through to the answer, and I know that you can do the calculation. So let's talk about something else. Yeah, no, 100 factorial is even, isn't it? So just to check, 100 exclamation mark means multiply all the numbers down from 100 down to 1 on the way through. No. This is even. So next question is the next number. Is 100 factorial plus 3 prime? And the answer to this one is similar. Whew, right, okay, I shouldn't tell you the answer. There's already many of you here. Ooh, that's worth noting. About 40 people left when this question turned up, or possibly during the triangle discussion. We're down to 75. That's fair enough. Cool. Yeah, 2 times, and then they've given me what it's 2 times. If you can remember what an even number is, then you could be a second-year student. Is that how this works? That's not how this works. Yeah, no. No, this is 3 even. Oh, 3 even is not a word, but you know what I mean. It's a multiple of 3. Sorry, sometimes I say threeven for multiples of 3. You know, like even is multiples of 2, so threeven would be multiples of 3. How far can we go? Oh my goodness, handwriting has gone again. How far can we go? I would not write that on the board. I would ask you out loud. I have also said it. How far can we go with this? Tell me some more. 100 factorial plus 4 is the next number. That feels like too stupid a question for me to ask, right? Is 100 factorial plus 4 prime? When you already know 100 factorial plus 2 is fine. That's on Tom Rock's maths channel as well. Why? Have I done it with Tom? I don't think I've done it with Tom. Okay, I don't think it's on Tom Rock's maths. Oh, how do I know 100 factorial plus 3 is a multiple of 3? Yeah, good question. Hiding inside this 100 factorial, which is, remember, this, all the numbers of the rainbow from 1 to 100, including 3. So it's 3 times the rest of them. Is a multiple of 3 because there's a 3. That is maybe a clue for what's going on here for this next part. How far can we go? Yeah, so I'm going to agree that 100 factorial plus 100 is not prime. And then I would like to claim that 100 factorial plus 101, I don't know. I don't know if this is prime. Maybe you do. It's not enough to just say that I've added a prime number here, right? Because, well, I've been adding prime numbers already, and that didn't give me primes. Maybe if you think you're adding a large prime now, well, how do you know that this isn't a multiple of 1007 or something? It's a massive prime factor, right? It could have all sorts. The trick that we've been using so far, that this is sort of multiple of something, stops working. Yeah, so you can go all the way up to 100. Ooh. Anonymous has linked me to a mysterious looking website where maybe I will find maths. Maybe. Yeah, cool. Then 100 factorial plus 102, you get an even number again. 100 factorial plus 1 has come up in chat as well, and I should admit that 100 factorial plus 1, I don't know. For that one I actually do, because of some maths from the Oxford Online Maths Club. This seems like a good moment to advertise the Oxford Online Maths Club. In January, once everyone's fed up of talking about maths, we do a different show on Thursdays where I get some Oxford students to talk about maths that they care about. And one of them, at one point, taught me some maths, which means that I now know that that's not prime, but it took a lot of maths to get there. It's a multiple of 1, but everything's a multiple of 1. Yeah, so someone in chat thinks not prime. How do we know if it's prime? Well, okay, apparently loads of number theory, but I'm not trying to test whether you've seen that number theory or not. So, okay, seems like what we've got then. What we've got is 99 consecutive numbers. By 99 consecutive numbers, right, I mean there are 99 of them, they're different, they're all in a row. That's what 99 consecutive numbers mean, one after the other. Going up from the smallest to the largest, there are 99 of them. None of them are prime. And then the question is there a set of 99 consecutive numbers, again, with exactly 1 prime? I used an online prime checker. Well, tricky, because 100 factorial is really large. I think that's probably too large for any algorithm I'm aware of. Is that true? 100 factorial is huge. 100 factorial is really big. Too big for any algorithm I know? That's not quite true. I'd be surprised if there's an online checker that could just do this. Oh, they've just gone for it. They've gone up to 100 factorial plus 229. Wow, not what I was thinking of. People in chat quoting Wilson's theorem. Multiple of 101 double factorial. Interesting. No, they mean 100 factorial and I'm excited. No, they mean 101 and I'm very excited. Oh, the rare double exclamation mark. Does this stream apply to Cambridge interviews? Hi, Vivian. This question is adapted from something that was used for a Cambridge interview many years ago. Part of a Cambridge interview used this question. It was the 1 year that I was interviewing for Cambridge. Cool. Right, what are we looking at? What on earth are we doing? Oh yes, we're looking for one prime in a set of 99 consecutive numbers. And one person's solution is to check for primes online until you find a prime. But of course, I don't just want one prime. And I don't want you checking online for primes. I don't want exactly one prime. I want 99 numbers where one of them's prime. So I want 98 composite numbers hanging around in there as well. So just finding a prime is okay, but what if it's the middle of a prime triplet? A prime triplet is better than a twin prime. A prime triplet is when you get 3 primes. A prime and then 2 more and then 2 more than that. And if this prime that you've just told me, 100 factorial plus 229, is one of those, then it won't be part of this kind of set of 99 consecutive numbers because they will include some of this triplet instead. Who's going to tell me? Who's going to tell me? Right, yes, okay. Right, 100 factorial plus 2 plus 100 factorial plus 100. Well, no, that contains no primes. I would like exactly one prime now. So the ones that you've told me, 100 factorial plus 2 up to 100 factorial plus 100 contains no primes. Yeah, good. Okay, and some people are putting sensible things in chat about thinking about intervals and counting how many primes there are. So I like this bit of the question because then you can get a candidate that you're interviewing to explain why that works or to think about where this is going. There's actually 2 ways you can do this part of the question. One of them is to, well, possibly what the person with the prime number checker online was thinking about is to slide upwards to think about how, as you move upwards, you might gain a prime by well, eventually you'll find a prime. There are infinitely many primes, and if you just move and look upwards, you might find a prime. Now don't look at my kind of triplet stuff. Look at find a prime and look at the stuff before. Cool. Yeah, shift the window up by 1 until you get a prime. Or Horatio says in chat, there you go. Shift it up by until you get one. At which point I can say, how do you know you're going to get one? You can say something like, there are infinitely many primes, so eventually we will find one. The answer to how far can you go is not forever. Like eventually you're going to hit a prime. I don't really know when, but you're going to hit one. I suppose I do if I believe that thing from chat, but I'm going to pretend I haven't seen posts in chat for this. Yeah, okay, good. So eventually you're going to hit prime. The other way to do this is to shift downwards to say if you look at smaller numbers, and as you come down, eventually you'll hit a prime. And then stop when you find a prime. We don't know when that's going to happen, but 100 factorial minus 1? I don't know if that's prime or not. 100 factorial minus 2? That one's not. 100 factorial minus 3? No, okay, there's loads of non-primes on this side as well, but maybe keep going until you get an interval with exactly one prime. Thank you, James. There you go. James in chat. I'm not certain that you're first, but I'm going to say that you're first. First person to say the prime triplet thing never happens at all. Aha. Yes, except for 3, 5, 7, where one of them is a multiple of 3, but also weirdly prime. Right, Adam's off. Bye, Adam. Okay. Countdown. Yep. So keep going up. Okay. Anonymous says, by shifting the end up or down, you're changing the endpoints. So the argument of no primes within that range on the whole is more correct. Yes. We would like one prime. So we're willing to shift until we find a prime. At which point, yeah, you're right. Our argument that there are no primes will fail. We found a prime. If you like, then as we shift upwards, either that number's a prime, in which case we stop, or it's not prime. Not for the reasons that we were discussing before, but just it turns out to not be prime. There's a possibility. In which case, you now have a new set of 99 consecutive numbers where none of them are prime. And you can do it again. You can shift, and you might find a prime. Ooh, nice. That's what we were looking for. Or you might find something that's not prime. Again, not for the reasons above. Maybe it's an even number, or maybe, oh gosh, this one's a multiple of 735 or whatever crazy thing up there. In which case, you say, that's not prime. Once again, I've got 99 numbers where none of them are prime. And then you can move up again. Keep going. Right, GP's off. Bye, GP. Good luck with your Trinity interview. Okay. What's the most amount of primes you can fit in an interval of 100? Ooh, there's a good question. Yeah. I think I've got an idea. But anyway, okay, so eventually you can convince me that there isn't a set of 99 consecutive numbers with exactly one prime. So is there a set of, lastly, 99 consecutive numbers with exactly two primes? Yeah, there we go. And the nature of this interview, when it happened many years ago, was we'd given the candidates some questions on a sheet of questions beforehand, so that they could get started exploring the questions beforehand. And I think that's what it said on the page. So it's sort of really hard to just do this without the previous parts. And then during an interview, if someone's got nowhere with it and you want them to try and do the question live, well, we could go through step by step. I'm currently interviewing for New College and we don't do that. We don't give people stuff in advance, but continue shifting up. So this shifting up is interesting because now we can talk about whether or not you find pairs of primes, right? We're trying to find two. If you shift upwards, then your strategy will work if there are infinitely many twin primes, for example, and also if those twin primes are surrounded by big gaps. Often people have got this kind of intuition that the gaps between the primes get larger, which is not precisely true. And it's an example of a thing that a candidate might say, but not really mean. I don't know, what does average mean, right? You don't mean the gaps between primes always get larger. I mean, 11 is followed by 13, and that's a smaller gap than 11 from 7. So the gaps can get smaller. 7 to 11, big step. 11 to 13, small step. 13 to 17, another big step. 17 to 19, small step. It's kind of all over the place, right? Sometimes big gaps, sometimes small gaps. There's kind of maybe some sense about an average, but I don't really want an average or a probability. I want to know exactly 2. Not probably 2, exactly 2. Yeah, so this logarithm thing is a probability fact, really. It's very hard to say a precise thing using that fact, I think. If you prove that there's a non-zero probability, then there exists at least one where there is at least one prime, I think. But you can say stuff like that, but it's not quite exactly 2 primes out of 99. Okay, and in chat, thinking about shifting the other way, if you're shifting down, I come up with a Cambridge student who got this question a few years ago. Amazing stuff. Who knows? Who knows, right? Cambridge student a few years ago got this question. Who knows? Right, okay. Somewhere out there. Cool. So shifting downwards works better because you know that for small numbers there are loads of primes. A good prompt for this question is, so far we haven't found any primes. We found things that are not prime. I haven't found any primes. Are there any prime numbers? Shifting down brings you towards the primes. There's one wrinkle, which is that if you bring the interval really all the way down to the first 99 numbers, there are now too many primes. There are an abundance of prime numbers in the small integers. The key idea, I guess, is that somewhere in between you had exactly 2. And we can make that more precise. Yes, good. Okay. We can't gain one at the top end. The problem is if you shift left, you might see blip, just one prime, and then you're hoping for a second prime after you've seen the first one. The problem is that there might be another big gap, at which point you'll lose the first one before you gain a second, which is very disappointing. You're looking for two. Maybe another one comes along, blip. The idea is that the change for how many primes you have in your interval can only go up by one, stay the same, or go down by one. So eventually it has to get up to sort of 23 or something for loads of primes in the interval. At some point, so in between, it must have gone through the number 2. Did we find an answer for one prime? We proved that it happens, but we didn't find an explicit formula for where it is. That's an example of a non-constructive proof. Constructive proof is when you find something, you also know where to find it. I don't know, if somebody says, do you have any clean socks? And you say, yes, here's one, then that's an example of constructive proof because you've demonstrated that there exists a clean sock by finding one. If somebody says, do you have any clean socks? And you say, yeah, I did laundry yesterday, then that's an example of a non-constructive proof, I think, where there definitely exists some socks that went through the laundry yesterday, but you don't have a specific example. You just know that some laundry happened. And this is the non-constructive sort of proof, where by shifting an interval to the right until we're sort of shifting where we're looking along, until we find a prime at the end, so that we get one prime, shifting along, we don't need to know when that happens. We just know that it will happen because there's infinitely many primes, so we're going to hit the next one at some point. Classic non-constructive proof, by the way. If we've got 5 minutes here, I think we've got 5 minutes. Is there a set of consecutive numbers with b primes? Oh, okay, you want to generalize it? Yeah. So the kind of extreme version of this question is there a set of 99 consecutive numbers with exactly 99 primes? I want all of them to be primes. That's a silly question, I think, because no, you can't have all of them be primes. That's greedy. You have strong feelings about the behaviour of some of these numbers from this set. There was a question in chat, what's the most you can have? I think it's not obvious. I think it might be 23. So you would do arguments about some of them being even. Some of them are necessarily multiples of 3 or multiples of 5. You'd eliminate things like that until you boil it down. If 2 primes are separated by 99, then you don't go up by 2. As you move the interval, you will gain 1 and simultaneously lose 1. So you'll gain 1 off this end and you'll lose 1 off that end. So it'll go up by 0. Kind of cancels out. You're only gaining primes on kind of the front end as you approach some primes, like Pac-Man going along gobbling up primes. As you approach them, you can only eat 1 at a time. And you might lose 1 off the end, but you can't eat 2 at once because they're on the number line. Like Pac-Man, is this working? I don't. Pac-Man with the. So with this video game from many years, and he has to eat the. Never mind. So advice for interviews, maths interviews, we're trying to use online whiteboards where we can. We've been in contact with some candidates in the past when we've shortlisted someone and said, can we use whiteboards? And they've said, can I borrow a whiteboard? We have worked something out before. Sometimes. Good. We can also do interviews where we don't use the whiteboards. And some colleges have decided not to bother with whiteboards, online whiteboards at all. Yeah, do you want to talk about negative numbers? Sometimes people talk about negative numbers and I have to put positive in here, right? When I talk about this. Then maybe we can get into my weird opinions about negative primes. Right, do you think -3 is prime? Not an interview question, just a kind of personal opinion. If you think -3 should be a prime, I don't know, then I'm on your side. Good. Oh, how do we get 2? So as you move the interval along, you start with 0, And as you move it along one by one, so this is not quite the right diagram, is it? Because I don't want to move it all the way along. I just want to move it a little bit. You get something new, you lose something off the end, pop, but you gain something new on this side. So the number of primes, well, it might go up by 1 if you gain 1 and you don't lose any. It might go down by 1 if you lose 1 but you don't gain 1. It might stay the same if you, nothing to see here, or if you gain 1 and lose 1 at the same time, simultaneously when you do the shift. That means that kind of on the graph of how many primes, you have a graph like this where this number line, exaggerated, goes 1, 2, 3. What's the kind of, this axis is going to be first number in your set. I should use hashtag again. First number in your set. And if it's 1, then you get loads of primes. And if it's 100 factorial plus 1 plus 2, then you get no primes. And there's this graph which can only go up by 1 or down by 1, and it can't jump by 2. So maybe it goes up and down, but it's over here it's about 20-ish, and down here it's 0. So somewhere in between it's going to go through 2. It's a good question. I like it a lot. That was a maths question when we did it a few years ago. Apparently someone who was asked this question is also talking about it on the internet, which is fun. I must find them. Right. And find out whether I interviewed them or not. Okay, good. I was going to do a non-constructive proof. I'm sort of having second thoughts. We're about to hit 500 comments in Slido, which is fun. There it is. It's someone getting an interview offer. Probably not for maths. Probably not for maths. Well, lucky now. Interview offer, like an invitation. No, never mind. Okay. Good, cool. Okay. This is a kind of strategy for this, which people get, I think, if you talk about it enough. 5 minutes. Non-constructive proof. I did the thing with socks, which would maybe given you the wrong impression that it's a laundry theorem sort of thing. Let's do a maths thing. The maths thing that I like is if A and B are irrational numbers, is A to the B rational? I haven't prepped this. Ever rational? And the answer is yes. And the proof works like this. Well, a proof. There are other proofs of this, including other just direct examples where you just find a sock and say, oh yeah, here's an example. But here's a proof that I like. Consider root 2 to the power of root 2. Case 1, if rational, then we're done. If irrational, consider, oh, now I've got a new irrational number, which I love. Consider root 2 to the root 2 to the power of root 2. That would be an example of A and B, both irrational numbers, but this one is equal to root 2 squared, which is 2, which is rational. So then we're done. So this proof demonstrates that there is an example of A and B both being irrational numbers where A to the B is rational, but it does not say which example. There are two possibilities. Either this thing is itself rational, or it's part of my solution, where I say it's the irrational number and I'm raising it to another irrational power. Either way, I get a working example. But I don't need to know which of those works. Good, I love that proof so much. And then there's always someone who says e to the I pi, and I guess, sort of. There's so much extra stuff going on in there. Is 100 factorial the first 99 consecutive numbers with no prime? I don't know. I do know. 100 factorial minus 2, 100 factorial minus 3, 100 factorial minus 4, all the way down to 100 factorial minus 99. No, it's not the first time. There's a cheeky related example with slightly smaller numbers. No follow-up questions. Please don't make me actually engage with the question of whether or not it happens before. It probably does. 9 factorial minus 1 is not prime. Good, spot, lovely. So sometimes n factorial minus 1 might not be prime. I mean 9 factorial, okay, good. Right, okay, applying as a gap year student. Yes, good. Oh, cool. People do that. Does it affect my chances or look bad on the application? Well, we'd like to know what you're up to. Do bad 2024 step grades. You don't actually, well, anyway, I mean, you don't have to do step if you're applying to Oxford. Okay, cool, right, good. Should I be happy I'm doing maths all serious because I'm talking to Oxford professors? Disclaimer, I am not a professor. I do interviews. I don't mind if you're happy or not in the interview. I'm not trying to assess people on whether they are doing a big fake smile or not. I'm just trying to do maths. If you feel that you have to act in a particular way, I'd encourage you to relax and just try and join in with the maths that's happening. We try to interview people multiple times. My personal opinion is that interviews are a bit like pancakes. The first one, you're kind of learning how they work and remembering how to do maths, finding out what they're like, and the other ones are a bit more confident, perhaps. That's what I'm like with pancakes, anyway. Which is one of the reasons that Oxford does multiple interviews. But I do want you to be happy more generally. Whether or not you're interviewed by Oxford, I hope you've enjoyed seeing some sort of maths questions. I hope you've enjoyed thinking about maths. I hope that you get some chances to do some maths questions with people, whether that's in an Oxford interview or whether it's at university or in between later on in classrooms or around the place, just trying to get on with solving some maths problems. And I hope you like that afterwards as well. If I'm seeing you for Maths Club in January, same YouTube channel, same sort of time slot, Thursdays at 5 o'clock in the new year, then I'll see you in January with a whole host of Oxford students who are going to come and explain maths topics to you that are nothing to do with admissions, just some fun maths. They're raring to go to tell you about. To start off with, I think we've got Fundamental Theorem of Calculus as the first one. I might be wrong, but something mentioned in passing was Fundamental Theorem of Calculus, which we're going to talk about at some point there. Can I show you a non-constructive proof about the order of numbers below the prime modulo prime number? Yeah, okay. If you'd like to see more of this sort of thing, well, we recorded all of them and they're on our YouTube channel. You could watch last year's interview questions live stream where I talked about slightly different questions but with some overlap. You can see that I did the same comments along the way, or you can watch different questions. The main Oxford Mathematics YouTube channel has other stuff like a few student lectures for tasters and some interviews with current researchers, other stuff. They occasionally let me go on the main channel to talk about some sort of nonsense like some mathematical objects or whatever. There's good stuff out there. I'm streaming on Twitch at the moment sometimes if you want to see more of me. Otherwise, I'll see you in the new year. That's the end of the Math live stream for 2024. Thanks for watching. Thanks for joining in Slido, in chat, YouTube comments, all of that stuff. And I will see you around. Someone says, when is Twitch back? Never went anywhere. Never went anywhere. Right, good. Okay. See you, everyone. And take care. Bye. Right, yes. Having failed to start the stream, I'm now going to fail to stop the stream. It's one of these. Oh, yes, it's this one to show you the advert for Maths Club. Bye.